students, welcome to IMS Academy. Myself Sandeep Adari. I have 10 plus years of experience in teaching the gate coaching in civil engineering, and especially I have taught so many times geotechnical subject. The intention of this gate score booster is very simple, my dear students. The agenda is, once you are aware, you have done all the hard work for preparation for gate 25. In this session, I would like to cover all the concepts in a broader picture and in which topics you need extra attention. So these are the things I am going to cover. Now my dear students, in geotechnical, if you tell me about this, geotechnical has two parts. One is the soil mechanics part, another one is the foundation part, my dear students. When I talk about soil mechanics, we have the topics like properties of soil, which will be a complete, which you can see that there will be 100% question. In addition to this, in addition to the properties of soil, we have topics like permeability, or we can say effective stress, or you can say the most important topic like consolidation, and some of the topics on the stress distribution. Very good afternoon, Matan. Very good afternoon. In addition to this, my dear students, let me tell you, in foundation engineering, you should have a strong hold on pile foundation, and also you should have a strong hold on shallow foundation, stability of slopes, and earth pressure. So in this session, when you if you like this session, please like it, share it, and in this session, without wasting your time, let me start the important topics here. So the first and the foremost topic we have is the properties of soil. The first and the foremost topic, and I am pretty sure there will be a question from properties of soil, which is can be a 1 mark question or it can be a 2 marks question, my dear students. Okay, this is for sure. Now see students, when I talk about this, see students, suppose if we consider here, suppose if we consider a soil mass, if I consider this as a soil mass, okay, in this we have soil particles, and in these soil particles, the voids are filled with air or it can be water. So if I take this diagram, this has voids, okay, and if this is solids, okay, my dear students, solids are nothing but the soil particles. So we can assume this as volume of voids, and we can assume this as volume of solids. Okay. Now my dear students, whenever they ask you important relations in properties of soil, they can ask you, the first question is, what is void ratio? A void ratio is defined as the ratio of volume of voids to the volume of solids. Agree, my dear students? Okay. Now my dear students, in GATE 2024, there was a question asked by the examiner, what do you mean by percentage of voids? Sir, see, when they ask you what do you mean by percentage, it is the actual upon the total into 100 is nothing but the percentage of voids. Now if I talk about porosity, if I use the word porosity, what exactly do you mean by porosity is, it is denoted by a letter N, my dear students. So porosity is given as volume of voids upon total volume. What, sir? Porosity is given by the formula volume of voids upon total volume. Now my dear students, percentage of voids means volume of voids by total volume into 100. So you should be very clear in the basic concepts. Why I am telling in this in detail is, these are the basis or these are the basic things for solving the other problems in soil mechanics and foundation. Now my dear students, when I talk about the total volume in a soil, it can be the summation of volume of voids plus volume of solids. What, sir? Total volume can be written as volume of voids plus volume of solids. Now my dear students, if I have taken common here volume of solids, this can be written as VV upon VS plus 1. So you are already aware, my dear students, what is VV upon VS. What do you mean by VV upon VS? Can anyone tell me? Sir, please try to reply in the chat box so that it will help you to revise the concepts. So total volume can also be written as volume of solids into void ratio plus 1. Now, whatever the formula you have, just plug in here and you will get the void ratio, porosity and void ratio relationship as N is equal to E plus 1 plus E. Okay. So, my dear students, the common question for void ratio, very good Piyush. So, the common question for porosity and void ratio is the relation is N is equal to E upon 1 plus E. Once your basic mass is clear, so here always remember that porosity will be less than void ratio because the denominator is more than the numerator. So obviously the porosity will be less than the void ratio. Now my dear students, similarly, if I talk similarly about some of the things like air content, degree of saturation. So these are the other terms which we have. Okay, we have air content. Now my dear students, in the definition itself, it is air content. What do you mean by air content, sir? How much amount of air is present in voids? So air content can be written as volume of air upon volume of voids. Where it is present, sir? Air is present in voids. So air content is given as volume of air upon volume of voids. Similarly, if I talk about degree of saturation. Sir, see, whenever this degree of saturation plays a very vital role when the soil is saturated or when the voids are completely filled with the water, we say that soil is fully saturated. So, my dear students, degree of saturation is represented as SR, that is SR is equal to volume of water upon volume of voids. So, let me tell you another important relation, my dear students. Air content plus degree of saturation is always equal to 1. Air content plus degree of saturation is equal to 1. Why? Because what is air content, my dear students? Air content is nothing but volume of air upon volume of voids. And similarly, what is degree of saturation? Volume of water upon volume of voids. Now, if we add volume of air and water, it is nothing but the total volume of voids. Hence, air content plus degree of saturation can be taken as 1. Now, let me tell you, my dear students, if they ask you percentage, means you have to just multiply with 100. Whatever the value you got, if you multiply with 100, it will be converted into the percentages. Now, similarly, my dear students, when I talk about the water content, the next one what I would like to discuss is the water content, or we can also discuss about the percentage of air voids. What is NES, sir? Percentage of air voids. Sir, see, we already have studied about air content. Then what is the difference between air content and percentage of air voids? Sir, air content is something related to voids. Percentage of air voids is something related to the entire volume. So, my dear students, NA, percentage of air voids, can be written as volume of air upon total volume into 100. And if you know the basic mass, I can replace this equation with, I will just multiply with volume of voids and I will divide with volume of voids to develop a relation between porosity and also the air content. Now, what do you mean by volume of air by volume of voids? This is nothing but air content. And what do you mean by volume of voids by total volume? It is nothing but porosity. So, my dear students, please keep a note of this. Percentage of air voids can be written as the product of the porosity and the air content. Now, let me tell you, my dear students, here please focus on the topics which are very important, because in properties of soil, we can expect a question. And remember, my dear students, please engage in the chat box if you have any queries or anything. Now, let me tell you, we have discussed about air content, we have discussed about degree of saturation, we have discussed about porosity and void ratio. Now, let me tell you, how can you represent a soil? A soil can be represented as a three-phase system. A soil can be represented as three-phase system, and soil can also be represented as two-phase system. This is one of the beautiful question in some of the exams. Okay. Now, why do you represent a soil in a three-phase and why do you represent a soil in a two-phase? Now, my dear students, if I talk about three-phase system, you can say it is partially saturated soils. What, sir? In partially saturated soils, soil is considered as three-phase system. Now, what do you mean by partially saturated soils? Voids can be filled with air or voids can also filled with water. But when I talk about two-phase system, voids are completely filled with air or voids are completely filled with water. Some of the two-phase system examples are like fully saturated soil, you can say fully saturated soil, or my dear students, you can say fully dry state also, or you can say what, sir? Fully dry state. So let me tell you, my dear students, how do you represent a soil? A soil can be represented as a three-phase system or a two-phase system. A three-phase system is nothing but a soil which has both air and water in the voids. A two-phase system is, it consists only either air or only water. So you should be very careful in this, in the problem solving. And why? Because these concepts will help you to understand the effective stress problems whenever there is a water table effect. Now, my dear students, how do you represent water content? How do you represent a water content? Now, let me tell you, my dear students, water content is defined as the ratio of weight of water upon weight of solids. What, sir? Water content is defined as the ratio of weight of water by weight of solids. So, they can ask you how to find out the weight of water also. Weight of water can also be written as water content to weight of solids. So, let me tell you, my dear students, how do you represent water content? Sir, water content is represented by oven drying method. We have various methods, but the most accurate method is the oven drying method. Which is the most accurate method, my dear students? The most accurate method is the oven drying method. So, usually the temperature, soil is kept in a oven for a temperature of 105 to 110 degrees for a 24-hour duration. Now, once you kept in the soil, that soil will have both water and other soil particles. Once you remove from the oven, it contains only the dry soil. So, how do you find out the weight of water? Means total weight minus the dry weight, you will get the water content. And remember, the oven drying is the most accurate method. Suppose in soils we have if the soil contains organic matter like peat and humus, all these are comes under organic matter. When the soil contains organic matter, the temperature cannot be more than 60 degrees centigrade. Now, similarly, but actually the problem with oven drying is, it might be accurate, but the problem is the duration. We have to wait for 24 hours. So, they are looking for the fastest method. What, sir? The fastest method to determine the water content. What, sir? The fastest method to determine the water content is the nothing but the calcium carbide method. The fastest method to determine, we call it as calcium carbide method. But what can be the question in the GATE exam is, which kind of gas is released in the calcium carbide method? It hardly takes 5 to 10 minutes, sir. If you consider here calcium carbide method, my dear students, when calcium carbide reacts with water, okay, it forms calcium hydroxide, and the amount of, based on the amount of acetylene gas released, the water content is estimated. We have similarly torsion balance method, radiation method, sand bath method. We have different methods. So let it be simple. Water content is defined as what, my dear students? It is the ratio of weight of water to the weight of solids. And let me tell you, which is the most accurate method? Oven drying method. Which is the fastest method? Calcium carbide method. Which gas is released in calcium carbide method? Acetylene. Very good, my dear student. Now let me tell you some of the important unit weights. Okay. The unit weights. So when I talk about the unit weights, my dear students, first we have is, what is the first one? Can anyone write in the chat box, my dear students? First one we have is the bulk unit weight. What is the first one we have, sir? First one we have is the bulk unit weight. So what exactly do you mean by bulk unit weight? Okay, bulk unit weight is defined as total weight by total volume. Okay. Now, my dear students, in total weight, you have what, sir? Weight of water, weight of solids upon total weight. Okay, total volume can be written as volume of air plus volume of water plus volume of solids. Now, my dear students, most of the people are aware or not, sir, you should be aware that this gamma, whatever this gamma you have, it will be classified into two things. One is gamma sat and gamma d. Sir, let me tell you, gamma sat and gamma d are not different from gamma. They are actually gamma, but they depend upon the state of the soil. So here, when I talk about dry unit weight, the voids are completely filled with air, or you can say that weight of water is 0. So here gamma d will be equal to weight of solids by total volume. Am I correct or wrong? Now similarly, if I talk about saturated unit weight can also be written as what? What, my dear students? The voids are completely filled with water in saturated unit weight. So when I say in the voids are completely filled with water, you have to be careful. So here gamma sat can also be written as weight of water plus weight of solids upon total volume. But when I am studying my BTech, I used to have this common doubt. Sir, what is the difference between bulk unit weight and saturated unit weight? The difference is simple, my dear students. You will find a difference in the volume. Here volume is considered as volume of air, water and solids. But here, if you consider, it is the summation of volume of water plus volume of solids. There is no point of volume of air because voids are completely filled with water. So volume of air will be 0. Am I clear, my dear students? Please respond in the chat box. So most of the students might have to understand what exactly is the difference between the bulk unit weight and the saturated unit weight. Agree. Now similarly, my dear students, we have unit weight of solids. Similarly, we have unit weight of solids. So what exactly do you mean by unit weight of solids? So when I talk about unit weight of solids, my dear students, they can ask you like this. Unit weight of solids is nothing but gamma s, which is equal to weight of solids upon volume of solids. I hope you are clear what is Ws and Vs. Ws is nothing but the weight of solids. Vs is nothing but the volume of solids. So here let me tell you, my dear students, for a given soil, always the weight and volume of solids is constant. Suppose you might have done compaction, you might have done consolidation. You might be doing compaction or you might be doing consolidation. But those things will have an impact on voids. It doesn't have any impact on solids. So for a given soil, always remember, my dear students, unit weight of solids is constant. So similarly, if I talk about unit weight of water, gamma W is equal to weight of water upon volume of water. What, sir? Gamma W is nothing but the weight of water upon volume of water. Now let me tell you, gamma W will be taken as 1 gram per centimeter cube or 1 ton per meter cube, or it is equal to 9.81 kilonewton per meter cube. Now my dear students, especially the students who are preparing for IES, Indian Engineering Service or state level exam, sir, whenever you are taking gamma W, please take either 1 gram per centimeter cube if the depths are given in centimeter, or 1 ton per meter cube if the depths are given in meter. But don't take this value because you will get lot of calculation. But at the end, final answer, whatever, if you get 2 or 3, then you multiply with 9.81, you will get the answer in kilonewton per meter cube. I hope you are clear. Now similarly, we have gamma dash, which we call it as submerged unit weight. What we call it as, sir? Submerged unit weight. Sir, this is different, completely different from saturated unit weight. So the condition of the soil here is submerged unit weight. And remember, my dear students, submerged unit weight due to the buoyancy principle, gamma dash will be equal to the gamma sat minus gamma W. So due to buoyancy principle, if you consider always self-weight acts downwards and the buoyancy force due to water acts upward. So here if you consider the resultant, the submerged unit weight is nothing but the gamma sat minus gamma W. Now let me tell you another equation also. In some of the beautiful problems in GATE, they can ask you the Archimedes principle. Okay, sir, they can ask you the Archimedes principle. So what actually is the Archimedes principle says is, suppose if I have taken a tumbler here, okay, if I have taken a tumbler and it is full of water, okay, now you have placed some cricket ball or any kind of ball here, okay, this you might have placed here. Now whatever the volume occupied by the ball, that much water will be displaced. So simple logic, my dear students, when you are solving the problems, you always remember that volume of solids will be equal to the volume of water displaced. Volume of solids will be equal to what, sir? Volume of water displaced. Is it clear, Piyush? Is this clear for Piyush, Sanjay, everyone? So here what is Archimedes principle, sir? If suppose a cricket, whatever the volume occupied by the solid body, that much amount of water will be displaced. Clear, sir? Very good. So this is what do you mean by the Archimedes principle. Now let me tell you the important relations, sir. And you can expect a question from this topic, from this formula sheet, okay, which I can say 100%. This will be recorded also. You can check after the GATE exam also, my dear students. After the GATE exam, you can check this video that, okay. Now see, students, the important relations are E is equal to water contained to G upon SR. Now, my dear students, let me tell you, in fully saturated soils, sir, what, sir? In fully saturated soils, degree of saturation will be equal to 1. Am I correct or wrong, sir? Similarly, my dear students, you know gamma is equal to gamma W into G plus E into SR upon 1 plus E. Okay. Now when they ask you, my dear students, here when I talk SR is equal to 1, if I substitute here, SR is equal to 1. Okay, if I substitute here, SR is equal to 1, it will become as gamma sat. So gamma sat can be written as gamma W into G plus E upon 1 plus E. Similarly, my dear students, if I substitute here, SR is equal to 0. I hope you are following, students. If I substitute SR is equal to 0, gamma D can also be written as gamma W into G upon 1 plus E. This is the another important formula we have. Agree? Very good, Sanjay. Now similarly, in terms of gamma D can also be written as 1 minus Na into gamma W into G plus 1 plus water contained to G. This is the formula with respect to what, sir? With respect to the percentage of air voids. With respect to the percentage of air voids. Now, my dear students, we also have, you know, total volume is equal to Vs into 1 plus E. Now, from this, for a given soil, void ratio, volume of voids is proportional to 1 plus E. So, from this, what you can write, sir? V2 by V1 is equal to 1 plus E2 by 1 plus E1 is equal to gamma D1 by gamma D2. In borrow pit and excavation problems, my dear students, this is a common question which you can expect. Okay, sir? Very good. Now, my dear students, let me tell you. So, here Na will be 0, sir. See, when volume of air is 0, then we can say Na will be 0. Okay, Sanjay? Na will be 0 when volume of air will be 0. Now see students, suppose here they can ask you what is true specific gravity. What, sir? What is true specific gravity? Now my dear students, when they ask you what exactly do you mean by true specific gravity is, true specific gravity is given as G. G is equal to gamma S upon gamma W. What is gamma S, sir? Unit weight of solids. What, sir? It is nothing but the unit weight of solids. What is gamma W? Unit weight of water. So for a given soil, true specific gravity is also constant. Why? Because constant upon constant is always a constant. Agree? Now, similarly, we have mass specific gravity. What, sir? Similarly, we have mass specific gravity. What is mass specific gravity here is, it is denoted by, mass specific gravity is denoted by what, sir? Gm. So, Gm can be written as, it is the ratio of gamma by gamma W, or gamma D by gamma W, or gamma sat by gamma W. It can be any of these three formulas. Why three formulas here? If mass specific gravity is asked in bulk state, then it is gamma by gamma W. If mass specific gravity is asked in dry state, gamma D by gamma W. If mass specific gravity is asked in saturated state, then it is gamma sat by gamma W. I hope you are clear. Now my dear students, this true specific gravity is denoted by a method called pycnometer method. It is denoted by what, sir? Pycnometer method. And it will be given by the formula G is equal to W2 minus W1 upon W2 minus W3, W2 minus W1, bracket close, W3 minus W4. Or see here, I will write the formula here. G can be written as W2 minus W1 upon W2 minus W1 minus of W3 minus W4. And here see students, what is true specific gravity is, sir, what is W1? Weight of pycnometer. What is W2? Weight of pycnometer plus solids. What is W3? Weight of pycnometer plus solids plus water. What is W4? Weight of pycnometer plus full of water. So my dear students, let me tell you, always for a given soil, true specific gravity is always greater than mass specific gravity. The reason behind is, for any soil, the maximum value, if you observe practically, is unit weight of solids will be the maximum volume. Okay. So, my dear students, let me tell you, quickly revise you the important concepts in properties of soil. So, what exactly do you mean by properties of soil? A soil can be represented as three-phase system, or it can be represented as a two-phase system. When in partially saturated soils, we represent in partially saturated soils, we represent the soil as three-phase system. In fully saturated or fully dry state, we represent the soil as two-phase system. Now coming to what do you mean by void ratio? It is the ratio of volume of voids to the volume of solids. And remember, for a given soil, void ratio is always greater than 0, because practically it is impossible to have soils with 0 voids. Now porosity is defined as the ratio of volume of voids to the total volume. The relation between porosity and void ratio is given by the formula N is equal to E upon 1 plus E. And let me tell you, my dear students, air content is defined as volume of air upon volume of voids. Similarly, degree of saturation is defined as volume of water upon volume of voids. And air content plus degree of saturation is always equal to 1. Similarly, porosity is also known as percentage of voids. If they ask you percentage of air voids, then it is Na, volume of air to the total volume into 100. And Na can be represented as porosity into air content. And if you see equation and borrow pit problems, V2 by V1 is equal to 1 plus E2 by 1 plus E1 is equal to gamma D1 by gamma D2. These are the problems related to the borrow pit and equation. And if I talk about the unit weight of unit weights, bulk unit weight is given as gamma is equal to gamma W into G plus ESR upon 1 plus E. Similarly, gamma D is equal to gamma W G by 1 plus E. Similarly, gamma sat is gamma W into G plus E upon 1 plus E. And you know gamma D is equal to 1 minus Na into gamma WG by 1 plus water content into G. And always remember, my dear students, for a given soil, weight of solids and volume of solids will be constant. And always this formula is simple, but you have to write in your formula sheet, total volume is equal to Vs into 1 plus E. And you know true specific gravity is gamma S by gamma W, and mass specific gravity is gamma by gamma W. And remember, water content is defined by the most accurate method is woven drying. And if you talk about the quickest method, then it is the calcium carbide method. Okay. Okay. I hope you are clear. Now see, students. Now when I talk about origin of soils or soil structure, I'll quickly go through it, Amma. When I talk about origin of soils, and also we have soil structure. So these soil structure is somewhat important, and you have to focus in some of the clay mineralogy. So what exactly is origin of soils is, how do soils are formed? That is the first question they can ask you. So, and soil is derived from a Latin word called solum. And you remember, soils are formed by weathering of rocks and decomposition of organic and inorganic matter. And organic soils are called what, my dear students? Colluvial soils. Example is peat, humus, cow dung and all. And soils are formed by a cycle known as geological cycle. How do soils are formed, sir? Soil is formed by a cycle known as geological cycle. In the name itself, geo means what, sir? Earth. So soils are usually formed in the earth, so geological cycle. So what are the different stages of geological cycle? One is the weathering. What do you mean by weathering? It is nothing but rubbing. In weathering, again, we have physical weathering, chemical weathering. Physical weathering is due to the natural effects. Chemical weathering is due to oxidation, hydration, leaching and all. And coarse grained you will find with physical weathering. Fine grained you find the chemical weathering. After weathering, these soils get transported. It can be transported by means of air, water. Suppose Godavari river is originated in Nashik. Along with the river, there will be some soil settling in Rajahmundry in Andhra Pradesh. So that is called transportation. After transportation, the soil gets deposited. And deposited, if it forms like a lump sum of mass, that is called upheaval. So what are the stages of geological cycle? You can say weathering, transportation, deposition and upheaval is the stages of geological cycle. Now my dear students, we have again two types of soils. Actually there is no name like this, but still, transported soil and non-transported. Transported means sedimentary soils. Soil particles created at one location and finally deposited at another location. When I talk about residual soils, soils which remain on the parent rock without any transportation is the residual soils. If the soils are deposited in lakes, we call lacustrine. If they are deposited in river, we call the most fertile soils, alluvial soils. If the soils are deposited by wind, we can say aeolian soils, and it is the most collapsible soil because just by blowing the air, the soil is formed. So they are very weak in structure. Similarly, in gravitation, we call colluvial soils, and we also have talus example, soils which are formed in the mountains, and the soils which are formed in sea, we call marine. Ice, we call glacier deposited soils. Okay, so see students, always remember surface, this point is important. Surface chemical and electrical forces are predominant in clay, whereas the gravitational forces are predominant in coarse grain or gravel and sand. You always remember Warwood clay means alternate layers of clay and silt. Morum means gravel mixed with red clay. Bentonite, it is a decomposed by volcanic ash. Now similarly, when I talk about soil structure, what exactly do you mean by soil structure, students? What do you mean by soil structure? Sir, based on the soil structure, the bearing capacity can also affect because it has indirect effect on shear strength. So what is soil structure is, it is the geometrical arrangement of soil particles in a soil mass. Okay, my dear students, geometrical arrangement of soil particles in a soil mass. Suppose if I consider this as a soil, some external force you try to disturb the soil, then that is called remolding. Suppose you went to some seashore, you will build some temple, means toys and all, again you will disturb. Means remolding causes the soil to loss of strength. Now there is a property in soil like elasticity, but we should not call elasticity, it is kind of property. We have a term called, and you are also aware, called thixotropy. What do you mean by thixotropy, sir? The phenomena of regain of lost strength with the passage of time with no change in water content is called thixotropy. What do you mean by thixotropy? The phenomena of regain of lost strength with the passage of time with no change in water content is called as thixotropy, which you might be clear. Now in soil structure also we have different structures, like we have is the first one is the single grain structure. What, sir? We have the single grain structure. Next we have is the honeycomb structure. Okay, honeycomb structure. I hope you are following, students. Okay, please comment in the comment box. Next we have is the flocculated structure. And next we have is the dispersed structure. Next what we have, sir? Dispersed structure. So my dear students, we have different structures like what, sir? Single grain structure, honeycomb structure, flocculated structure and dispersed structure. So what exactly do you mean by single grain structure? Sir, in single grain structure, the soil particles are assumed in the form of spheres and they are arranged in a cubical array. Okay, in this you should be aware that in the loosest state, the void ratio will be maximum, which is equal to 0.91, and in the minimum state, if I talk about the densest state, the void ratio will be minimum, which is 0.35. Now honeycomb structure, a honeycomb structure is something which is formed in this way. It is something like earrings. Okay, in the center you can say there is no, you can say it is hollow in nature. What, sir? It is hollow in nature. So what is honeycomb structure is, it is absorbed in fine sands and silts. Just with small change, means under small vibration and shocks, the structure will collapse. Similarly, if you talk about flocculated structure is something which is formed due to the edge to face orientation. Sir, when an edge and a face are orientation, it is obviously due to, it is formed by the net attraction between the soil particles. When there is an attraction, the soil particles come closer. In this way, the soil has high shear strength, low compressibility and high permeability. Similarly, if I talk about dispersed structure, it is formed due to the face-to-face orientation. In this, soil has, you can say, less shear strength, high compressibility and low permeability. I hope you are clear with the different types of the soil structures. Now, similarly, my dear students, let me tell you one important thing again. Here we have clay mineralogy. What, sir? We have clay mineralogy. What exactly do you mean by clay mineralogy is, we have first one is calonite. What, sir? Calonite. What is calonite is, it is the most stable clay mineral. What is calonite, sir? Remember, my dear students, if you see Ganapati, means in Ganapati ideal or okay, you will have this calonite because it contains China clay, sir. When do you say that a clay mineral is most stable? If it has no swelling and shrinkage. Name the clay mineral which is the most stable is calonite. Next, another gate question, this one, Amma. They have asked you this. Name the clay mineral. Name the clay mineral which is formed by potassium ions. Name the clay mineral which is formed by potassium ions is nothing but illite. What, sir? Name the clay mineral which is formed by potassium or K ions. Usually K is the, it was represented potassium as K. Now if you see nomenclature, so if you see the clay mineral which is formed by potassium ions, we call it as what, sir? This is call it as, we call it as illite. Okay. Now what is the most stable clay mineral, sir? Calonite. Similarly, which is the most unstable mineral? What they can ask you, sir? Which is the montmorillonite. Which is the most unstable clay mineral is what? The most unstable clay mineral is montmorillonite because it is formed by water molecules. Sir, when do you say that a mineral is unstable, my dear students? A mineral is said to be unstable if it has no swelling, if it has more swelling and shrinkage. If it has no swelling and shrinkage, then we can say it as kaolinite. I hope you are clear with the clay mineralogy. Now, similarly, my dear students, we should have an idea on specific surface area. What is specific surface area? It is the surface area of soil particles present in unit weight. What is specific surface area? Again, I am telling you, suppose it is the surface area of soil particles present in unit weight. And remember, my dear students, in this specific surface area, finer the soil, you should always understand this point. This can also be a gate question, sir. Finer the soil, higher the specific surface area. And remember, my dear students, if I ask you in the specific surface area of colloids, what's the specific surface area of colloids is greater than clay, specific surface of clay upon silt, because see here, sand and gravel. I told you already, finer the soil, higher the specific surface area. So if anyone asks you what is specific surface area, you always remember that it is the surface area of soil particles present in unit weight. Now similarly, my dear students, they can ask you about diffuse double layer. What, sir? They can ask you about the diffuse double layer. Sir, what do you mean by diffuse double layer? What do you mean by diffuse double layer? So here diffuse double layer is nothing but the layer on the clay surface. What, sir? The diffuse double layer is nothing but the layer on the clay surface up to limit of attraction due to the electrical forces is nothing but the diffuse double layer. Okay, sir. Actually, in diffuse double layer, they will replace the water which is held in this zone of diffuse double layer. We call it as adsorbed water. And if you replace that, because adsorbed water will cause plasticity, you have to replace that absorbed water with kerosene, which is a non-polar liquid. Now, my dear students, let me discuss about the another important topic, that is index properties, and soil classification. Sir, when I talk about index properties or soil classification, sir, please understand here, index properties are useful for classifying. What, sir? These are useful for classifying and identifying the soil. What, sir? Index properties are useful for classifying and identifying the soil. And remember, my dear students, it also gives rough estimation of engineering properties of soil. It also gives what, sir? Rough estimation of engineering properties of soil. Sir, what can be the engineering properties, sir? What can be the engineering properties? Engineering properties can be what, sir? Permeability. Okay, engineering properties can be permeability, or it can be shear strength. Okay, usually coefficient of permeability is represented by K. That is the reason I have written there K, sir. Permeability, shear strength, or you can also say compressibility, or you can say what, sir? Compressibility. You can say it as compressibility. So, my dear students, how do you represent how do you give is, it is nothing but the permeability, shear strength and compressibility. Now, let me tell you, my dear students, here we have one thing, sir. Now, see students, if I talk about if there is a percentage of, here we have a graph between particle size dia, here we have a graph between particle size dia, and if I talk about percentage of passing is also called as what, sir? Percentage of finer. It is also called as what, my dear students? It is also called as percentage of finer. Here it is called particle sized area or percentage of finer. Now here if I talk here, this is the hump shape and this is the steep shape, and here we have the shape called S shape. So my dear students, this is called a uniformly graded soil. What is this called, sir? Uniformly graded soil. Why it is uniformly graded soil? Now please see here, students. Here all the soil particles are of same size. Here this is called what, sir? This is called hump shape. What do you mean by hump shape here, sir? Some particle sizes are missing. So here we call this soil as poorly graded soil. Poorly graded soil means some particle sizes are missing. Similarly, if you consider here S shape, this is S shape, sir. So all the particles are present, so it is called as well graded soil. So my dear students, so based on this we call it as what, sir? Particle size distribution curve. What we call this as? Particle size distribution curve. This is the particle size distribution curve. Now similarly, my dear students, we have two things. We have two things which are very important in index properties also. So here, before going to the two things, let us understand what are the parameters which we will study. Here we have a term called D10. Okay, D10 is a term which we call it as effective size. What is D10, sir? It is a term which is called what, sir? Effective size. Now my dear students, when I talk about D10, you are telling it as effective size. What do you mean by effective size, sir? It is the size of the sieve where 10% of the soil particles are passing. Always remember, D10 means it is nothing but nothing new. It is nothing but the sieve size where 10% of the soil particles are passing. Now we have terms like CU, what we call it as coefficient of uniformity. What, sir? CU is called coefficient of uniformity. For well-graded gravel, CU should be greater than 4, and for well-graded sand, CU should be greater than 6. Now here you can say here, CU represents what, sir? CU represents the particle size range. What, sir? CU represents particle size range. CU represents what, my dear students? CU represents the particle size range. Similarly, my dear students, CU is also written as, it is given by the formula D60 upon D10. What, sir? CU is always written as what, my dear students? It is written as D60 by D10. What do you mean by D60 by D10, sir? Here D60 is nothing but 60% passing. D10 means 10% passing. Similarly, we have coefficient of curvature. What is coefficient of curvature is, it is given by the formula D square 30 upon D60 into D10. What, sir? CC is given by the formula D square 30 upon D60 into D10. So here always remember, my dear students, what actually is coefficient of curvature? It represents the shape of the curve. What, sir? It represents the shape of curve. Okay. Now similarly, see students, when I talk about coarse grained soils, what are the things which are helpful for classification of coarse grained is, one is the relative density. What, sir? One is the relative density and other one is the sieve analysis. Now my dear students, if I talk about relative density, okay, see, important thing, my dear students, relative density is also known as density index. What is relative density, sir? Relative density is also known as what, sir? Density index. And remember, here when I talk about density index, it is given by the formula ID is equal to E max minus E upon E max minus E minimum. Sir, there was gate question even in 23, I think, or 24. But let me tell you, they have given in dry unit weights. Always remember, if it is E max, if you want to have this formula in dry unit weight, E max means it will be gamma D will be minimum. So 1 by gamma d minimum upon 1, what is E? 1 by gamma d upon 1 by gamma d minimum minus 1 by gamma d max. So this is the formula which they have asked recently in the GATE exam. So you should always know that dry density and void ratio are inversely related. Okay, so my dear students, if you consider the range also, if the density index is between 0 to 50, we will consider the state as very loose state. What sir? If the consider the state as very loose. Similarly, if the density index is between 15 to 35, we take it as loose state. Similarly, 35 to 65, we take it as medium dense, or you can say low dense. Low dense. 65 to 85, you can say dense. And more than 85, you can say highly dense, because based on the density index also, you will understand whether the soil is highly dense or low dense. The other thing we have which is useful for classifying the coarse grained is nothing but the sieve analysis. Okay sir, the next one we have is what sir? Sieve analysis. So what you have to do in sieve analysis sir? What you have to do in sieve analysis, my dear students? In sieve analysis, always remember that we have a table kind of stuff. First, sieve size, next weight retained, next percentage weight retained, next you do cumulative weight retained, and next to last one you will do percentage finer or percentage passing, which is 100 minus that. Okay, suppose first is what sir? Sieve size, next weight retained, percentage weight retained. How do you find out percentage weight retained? Weight of individual sieve upon total weight into 100. Similarly, you will find the cumulative of those values, and after that percentage finer is given by the values 100 minus x. So you will calculate the sieve analysis. I hope you are clear. Now my dear students, once you are done with the coarse grained soils and relative density and all, next one we have is what sir? See, next we have is the fine grained soils. Sir, next we have is the fine grained soils. Sir, in fine grained soils, we use mostly sedimentation analysis, or we can say Atterberg limits. What sir? Sedimentation analysis, or you can say Atterberg limits. And remember my dear students, sedimentation analysis is based on Stokes law. Stokes law is valid between 0.2 micron to 0.2 mm. Why the Stokes law is valid for 0.2 micron and 0.2 mm is, if it is more than 0.2 mm, turbulent flow will happen. If it is more than if it is less than 0.2 micron, then Brownian movement will happen. So that is the reason it is applicable for only for what's the particles of sizes ranging from 0.2 micron to 0.2 mm. And sedimentation analysis is based on what? It is based on which law? We can say Stokes law. And here Stokes law is based again on settling velocity, which is equal to g by 18 into s minus mu 1 into specific gravity into particle size upon viscosity. This can also be approximately written as 902 d square, where d will be substituted in mm and velocity you will get in mm per second. Are you getting me sir? This is the formula. And in sedimentation analysis also, we have one is what sir? Hydrometer method and pipette method. What sir? We have hydrometer method, and next one we have is what sir? Pipette method. And remember my dear students, when I talk about pipette method, it is the standard method of sedimentation. What sir? We have the solution here. We have this solution. What is this solution sir? Suppose if you have a pipette in this way, okay. This we call it as dispersion solution. They can ask you this question directly sir, because see the soils which are at velocity time t1, they will be at here, okay. At time t2, they will be at here. Now if you measure the distance between them, you would know what is the settling length. So settling velocity is nothing but distance by time. By finding the time difference and the length, you will get the settling velocity. But here what is the dispersion solution? You should understand my dear students. What sir? What do you mean by dispersion solution? And here please understand students, A dispersion solution contains 7 grams of sodium carbonate and 33 grams of sodium hexametaphosphate. What does dispersion solution contains, sir? It contains 7 grams of sodium. It contains 7 grams of sodium carbonate plus 33 grams of sodium hexametaphosphate in 1 liter of solution. Sir, the procedure will be same for hydrometer, but in hydrometer, my dear students, you should understand that corrections are important. Meniscus correction is always positive, dispersion agent correction is always negative. So, hydrometer method you should know. Now, the most important one which we want to discuss here is the Atterberg limits, or you can say Atterberg limits are also called as what, sir? Consistency limits. Atterberg limits are also called what, my dear students? Atterberg limits are also called as consistency limits. What are Atterberg limits or consistency limits? Let me tell you. Now see students, what are Atterberg limits or consistency limits? These are the water content with what these are actually means. These are the water contents. What, sir? These are the water contents at which soil passes from. These are the water contents at which soil passes from one state to another state. One state to what, sir? Another state. Now see students, here if I talk here in consistency limits or Atterberg limits, it is a graph drawn between volume and what, sir? Water content. Atterberg limits is a graph drawn between what and what? It is a graph drawn between volume and water content. And we consider this as what, sir? This is called as dry volume. And what is this, sir? We call it as shrinkage limit. And what is this, sir? We take it as plastic limit. And what is this, sir? Liquid limit. Similarly, this is called the volume at plastic limit and this is called volume at liquid limit. Now similarly, we consider this as what state, sir? This we consider as liquid state. This we consider as plastic state and this we consider as what, sir? Semi-solid state and this we consider as solid state. So here if anyone asks you what is Atterberg limits or consistency limits, these are the water content at which soil passes from one state to the other state. Here we have liquid limit, plastic limit and dry volume. Similarly, we have shrinkage limit, plastic limit and liquid limit. Sir, see here from the graph, it is evident that, sir, as you move towards the right, the values will increase. So, it is evident that liquid limit is greater than, plastic limit is greater than shrinkage limit. Okay. Now, my dear students, what is liquid limit? So, liquid limit means it is the minimum water content at which the soil has small shear resistance. After if you cross the liquid limit, it will not have any shear resistance. And sir, it is also defined as the water content, you can say the water content at which 25 number of blows is also can be a liquid limit from the graph. Or you can say The other meaning of liquid limit is, practical limit is, suppose if you are applying a number of blows, at 25 number of blows, what will be the water content, where it shows linear behavior, okay. Or we also have flow curve. Flow curve gives you idea about the shear strength, what's sir? And remember, in a flow curve, it is a graph drawn between water content and number of blows. Suppose this is the, what's sir, water content and number of blows. So okay, to make it straight line, I applied logarithm to the number of blows. So what is flow index, sir? Flow index, sorry, this is flow curve, we call it as flow curve. Flow curve gives you idea about the shear strength. Sir, it is simple. If you apply more number of blows, then the soil is dense. If you apply less number of blows, less number of blows, you will say that soil is loose. So flow curve gives you idea about what, sir? Shear strength of the soil. And what is flow index? What is flow index, sir? Flow index is given by IF is equal to what, sir? W1 minus W2 upon log of N2 by log of N1. Okay, just go through it, Amma. See, just be online, students. I'll be back in 2 minutes. Hello, students. Am I audible, sir? Please respond, Amma. Am I audible? Am I audible, sir? Okay. Next, see, students, we also have shrinkage limit. Sir, see, what is shrinkage limit is? It is the maximum water content up to which any further loss of moisture will not cause any change in volume. If you see here, up to shrinkage limit, the volume is what, sir? How is the volume? The volume seems to be constant. Yes or no? There is, even though there is a loss of moisture, there is no change in the volume. So what is shrinkage limit is? It is the maximum water content up to which, what, sir? It is the maximum water content up to which further loss of moisture does not cause any change in volume. Any change in what, my dear students? Any change in, okay. I hope you are clear. Am I audible, sir? Okay. So this is what do you mean by shrinkage limit. And shrinkage limit is also defined as the water content at which the soil is fully saturated, or it is the minimum water content. You can say shrinkage limit is the minimum water content at which the soil is fully saturated. You can say it is the minimum water content at which the water is fully saturated. Okay. Now, my dear students, if they ask you what is shrinkage ratio, okay, this is very important, Amma. If they ask you what is shrinkage ratio is nothing but the shrinkage ratio is what, sir? Volume change in terms of dry volume. What, sir? Volume change in terms of dry volume to the corresponding change in water contents. To the corresponding change in water contents. Now, my dear students, please see here. So, here if they ask you what is shrinkage ratio, you can also write it as mass specific gravity at dry state. What, sir? It is the mass specific gravity at dry state, or you can also say that it is nothing but change in volume VL minus VD upon VD upon WL minus WS. Okay. So, what is VL? What is VL, sir? Am I audible, students? What is VL? Volume at liquid limit. What is VD? Volume at dry state. So, this can also be written, or shrinkage ratio can also be written as change in volume. That is what, sir? VP minus VD. What is VP minus VD? It is the change in volume from plastic limit to dry state expressed in terms of dry volume to the corresponding change in water contents. Now, similarly, my dear students, if they ask you what is this numerator term, this we call it as volumetric shrinkage. This we call it as what, sir? Volumetric shrinkage. So, what is volumetric shrinkage, sir? Sir, please listen here. Volumetric shrinkage is simple. So, volumetric shrinkage means volume change expressed in terms of dry volume. When you say volume change expressed in terms of dry volume, then it is volumetric shrinkage. Now, similarly, they can ask you what is plastic limit, sir? Sir, what is plastic limit means if you take a soil sample, you will add some water and you will make a rope of 3 mm. It will not break. This is called a thread test. Okay, we call this test as thread test. Now, similarly, my dear students, we have different indices. This is also very important, sir. We have different indices, okay, or we can have indices, we can say, they can say. Sir, what these different indices means? In soil classification, these indices will be helpful, okay. Now, see, students, what is plasticity index? What we call, sir, IP. IP is equal to plasticity index. That is, it is the difference between liquid limit and plastic limit. So, what we call IP here? IP is nothing but what, sir? Plasticity index. What do you mean by IP? IP is nothing but what, my dear students? IP is nothing but the plasticity index. Similarly, if I talk about toughness index, it is nothing but IP by IF. Sir, I told you what is IF? IF is nothing but what, sir? Flow index. So, here IF is the flow index, IP is the plasticity index. And you know what is IF? I told you it is from flow curve. W1 minus W2 upon log of N2 by N1. This is the formula which is used for toughness index. How hard is the soil? All these indices will help you to classify the soil. Similarly, we have IS. What is IS, sir? IS is nothing but the shrinkage index. IS is nothing but what, sir? Shrinkage index. And shrinkage index is given by the formula WP minus what, sir? WS. This is what do you mean by shrinkage index. I hope you are following, my dear students. Now, similarly, my dear students, we also have liquidity index. Liquidity index is given by the formula W minus WP upon IP. And next we also have consistency index. Consistency index is given by the formula WL minus W upon IP. Now my dear students, these consistency index or liquidity index, here if you add these two, consistency index plus liquidity index, this is always equal to 1, sir. Why? Because these will understand in the soil characteristics related to the compressibility and consistency and the liquidity. Now my dear students, there are two terms. What is plasticity and what is consistency? Sir, see, the consistency means it offers resistance to deformation only. Plasticity means it can deform, but it offers resistance to rupture. That is the only difference which you consider the difference between consistency and liquidity index. Now, my dear students, we also have another important factor that is called activity ratio. This is very important, sir. What, sir? We have a term called activity ratio. Now, when I talk about the concept, what do you mean by activity ratio? Activity ratio is represented as A, and this is given by the formula IP upon percentile C. Okay, sir. Activity ratio is given by the formula IP upon percentile C. So, here what do you mean by percentile C is, this is the percentage of clay fraction. Suppose a silty clayey soil, they can percentage of clay fraction. Clay, silty sand. Sir, you should be understanding in a soil, if they give you silt content as 50, you cannot take that as C or 40. Silt means total is 100. In that, if you remove the silt content, then you will get the clay content. So, here what is IP is? IP is nothing but the plasticity index. What is IP, sir? IP is nothing but the plasticity index. Now, you can ask me, sir, why do you want to study about activity ratio? Remember, my dear students, the activity ratio will help you to understand the swelling and shrinkage characteristics of the soil. What, sir? The activity ratio will help you to understand the swelling and shrinkage characteristics of a soil. What, sir? The swelling and the shrinkage characteristics of a soil can be understanding using the plasticity index. Sir, swelling is nothing but bulging and shrinkage is nothing but what, sir? Volume reduction. So, always remember, my dear students, activity ratio is defined as the ratio of plasticity index to the percentage of clay fraction. The swelling and shrinkage characteristics of a soil are represented by a number called activity number. Now, my dear students, if you see, if the activity ratio is, if suppose we can say, if the activities ratio is less than 0.75, then we say low active. Low active means it has less swelling and less shrinkage. If the activity ratio is between 0.75 to 1.25, we consider it as moderate. What, sir? We consider it as moderate. And if the activity ratio is more than 1.25, then we consider it as highly active soil. Now, my dear students, let me tell you, if I talk about Mont-Mornolite soil, students, if I talk about the Mont-Mornolite soil, remember that in Mont-Mornolite, the activity ratio is greater than 4. That itself says that it is having very high swelling. Are you getting me? So, remember the swelling and characteristics are represented. Now, similarly, now we will be going into the concept like soil classification. What, sir? Now, I will be going to discuss the soil classification. Sir, actually in soil classification, based on the particle size only, my dear students, if I consider here, sir, based on particle size only, soil particles are classified. Suppose if I take it as 2 micron, then below 2 micron we call it as clay. And 2 micron to 75 micron, we call it this as silt. Okay. Now, similarly, my dear students, if I talk about here, if it is up to 0.425 mm, then we consider this as fine sand. What, sir? We call it as fine sand. Similarly, if I talk here up to 2 mm, okay, then we call it as coarse sand. Sorry, medium sand. We call it as medium sand. And remember, my dear students, if I talk up to 4.75 mm, then we call it as what, sir? Coarse sand. Then we call it as what? Coarse sand. So always remember, for a value of 75 micron to 4.75 mm, all this is sand. But again here 0.425 mm, here if it is 0.425 mm, it is called what, sir? Then it is called fine sand, medium sand and also coarse sand. And 4.75 mm to 80 mm, it is called cobble. Okay, more than 80 and are you getting, sorry, gravel, sir, 4.75 to, sorry, 4 points, this we call it as gravel. Okay, up to 80 mm. From 80 mm to 300 mm, we call it as what, sir? Cobble. And more than 300 mm, we call it as boulder. Okay. So how do we classify this soil, sir? All these soils are classified based on what? Based on particle size. Based on the particle size, we are going to classify what is clay, silt, sand, gravel, cobble and boulder. Okay. Now see students, there was an actually Cascades. Okay, let me tell you in this way. Sir, there are some organizations like AASHTO, American Association State Highways, Transport Officials, Highway Research Board, and we can say Public Road Administration. These are the organizations, sir. What these organizations they have done is, they want to identify the soil, but sir, they want to identify the soil, they want to identify the soil which is best suited for pavement. What, sir? Which is best suited for pavement design. They want to identify the soil which is best suited for pavement design. Now, my dear students, we have here A1, A2, so on up to, they have classified into 7 groups. And always remember, sir, smaller the group number, better is the soil for pavement. What, sir? So, smaller the group number, better is the soil. In this, which is the better, you can ask me. So, you can write here, smaller the number, better is the soil. I hope you are following, students. Now, see students, suppose if you have 2 soils, suppose if you got both the soils as A2 and also another soil is also A2. Now, in this case, you want to identify the soil which is the best soil. In that case, what comes, sir? In this case, if you both are same, then comes a concept called group index. Then comes a concept what, sir? Group index. What is group index is? Group index is used to indicate the quality of the soil within the same group. What, sir? It is used to indicate the quality of soil within the same group. Okay. And here also, my dear students, group index also varies from 0 to 20. Here also same thing, sir. Smaller the group index, better is the soil for pavement. Now see students, we have Unified Soil Classification System. Okay. Sir, this system, Unified Soil Classification System, was introduced by Cascades. Who has introduced this? He has introduced the Cascades. On what factors Unified Soil Classification System will depend on? Can anyone tell me, sir? On what factors? It depends upon the grain size distribution, plasticity characteristics like liquid limit, plastic limit, shrinkage limit, and the plasticity characteristics, and then one we have is compressibility. So based on this, my dear students, they have classified the soil into what, sir? They have classified the soil into 18 groups. What they have done, sir? They have classified the soil into how many groups? Based on this, they have classified the soil into how many groups, sir? 18 groups. So here, in these 18 groups, what they have done? Okay, what they have done, sir? They have done as CL, you can say clay is represented by what, sir? C. Okay, clay is represented by C, sand is represented by S, gravel is represented by G, and silt is represented by what, sir? Silt is represented by M. Okay, this is how you classify the soil. Agree? Now see, sir, again they can call you as silty sand. Sir, what does it indicate? If they, how do you represent silty sand? They can ask you. Sir, as you move towards the right, the composition increases. So it should be written as, if suppose, yes, first it is what, sir? Sand. Then what it is? Silt. So it will be SM. If they call you well-graded gravel, then it will be GW. Suppose similarly, if they ask you well-graded gravel, if they ask you what is well-graded gravel, it is represented as what, sir? GW. So, okay. So what is the first quality of the soil? It is gravel. And what is the condition of the soil? Then it is well-graded. Now another important point, sir. Let me discuss you. One second, students. Now see, students, here we call this as what, sir? Plasticity chart. What we call this as? Plasticity chart. What is plasticity chart is? Now see, students, how do we develop this plasticity chart? Let me tell you. If liquid limit is less than or equal to 35, what, sir? If liquid limit is less than or equal to 35, we call it as low compressible. What, sir? If liquid limit is less than or equal to 35, then we call it as what, sir? Low compressible. Okay. Next, if liquid limit is between 35 to 50, then it is called intermediate compressible. Then it is called what, sir? Intermediate compressible. And if liquid limit is more than 50, we call it as highly compressible. Okay. And remember, my dear students, above A line, where now this is important, sir. What is the equation of A line? Equation of A line is what, sir? Equation of A line is nothing but 0.73 into WL minus 20. This is the equation of A line. Yes or no? So here see, this we call it as what, sir? This we call it as A line. Now my dear students, see, this I will assume as 35, this I will assume as 50. So this is the water liquid limit ratios, okay? And here we have what, sir? Here we have the IP, that is plasticity index. Now let me tell you, my dear students, okay, if I consider here, if the IP index is between 4 to 7, it has both the nature of clay and silt. What, sir? If IP is between 4 to 7, what, sir? If the plasticity index is between 4 to 7, it has both the natures of clay and also silt. Now see, students, above A line, we call it as what, sir? CL. Sir, see, this 35 to 50, what's our intermediate? More than 50, highly compressible. Here we have MH or OH, silty, highly organic silt, or here it is, you can say MI or OI. This is ML or you can say OL. OL means organic soil, sir. Okay, now see students, let me explain you with an example. Suppose they have given you, for example, they have given you liquid limit as 40% and plastic limit as what, sir? 20%. Okay, now they can ask you to classify the soil. So in this case, first of all, find out what is the equation of A line. IP is equal to what, sir? 0.73 into WL minus 20. So here what is the WL, sir? You can say W73 0.73 into 40 minus 20. So you can write it as 14.6. This is the IP value, right, sir? Or this is the location of A line. Now, what is the given? If you see, what is plasticity index? That is WL minus WP, right, sir? WL minus WP is how much, sir? 40 minus 20. This will be equal to how much, sir? This will be equal to 20. Am I correct or wrong? Now, see students, if I have drawn the chart here, okay, A line is located at where, sir? A line is located at 14.6 value. Now, where does this 20 lie? 20 is lying above. So, it is evident that it is clay. Now, to check whether it is intermediate, low compressible or highly compressible, what is the liquid limit here? It has 40 percentile. So, the answer will be CI, that is intermediate clay. Now, how do you distinguish clay and organic soil? This can also ask you, sir. How do you distinguish? How do you separate or how do you differentiate or distinguish? How do you distinguish silt and, are you following, my dear students? How do you distinguish the silt and also organic soils? Sir, see. Sir, first one we have is the color. Color is what, sir? Dark gray in color. What is color? Color is in dark gray in color. Or you can say order will be bad or liquid limit after woven drying. What, sir? Or liquid limit after woven drying. What, sir? Liquid limit after woven drying reduces by 25%. Then reduces by 25%. Then we call it as what, sir? Organic soils. So this is how do you differentiate organic and silty soils. Now the most important part, my dear students, let me tell you, that is the important topic, that is permeability. Sir, when I talk about permeability, what do you mean by permeability, students? This is the one question I would like to ask you. Suppose if you have a tank, it has a valve, tap. If you close the valve, water will not flow. If you open the valve, water will flow. So what is permeability means? It is the property of the soil which allows the passage of flow. Or simple words, water flowing capacity in the soil is nothing but permeability. Now, my dear students, according to Darcy's law, what, sir? According to Darcy's law, what Darcy's law has told is velocity is proportional to hydraulic gradient. What, sir? Darcy's law says that velocity is proportional to what? Hydraulic gradient. What do you mean by hydraulic gradient? It is nothing but the loss of head per unit length. Or suppose if you consider this as a pipe, and if you consider head at H1, at this point as H1, and head at this point as H2, and this difference if I consider it as L. So what is hydraulic gradient, sir? Hydraulic gradient is nothing but H1 minus H2 by L. So this you can call it as hydraulic gradient. Clear, sir? So now, my dear students, when velocity is proportional to I, what I have written? Velocity is proportional. Suppose it can be written as velocity into some constant. So V can be written as what, sir? V is equal to IK. So here, my dear students, what do you mean by K, sir? K is nothing but the coefficient of permeability. So what is coefficient of permeability ability is, it will tell whether the soil has more flow capacity or whether the soil has less flowing capacity. So see, my dear students, so according to Darcy's law, velocity is proportional to hydraulic gradient. Now, what are the factors affecting permeability? So for the factors affecting permeability, my dear students, if you can remember this formula, okay sir, if you can remember this formula, if you can remember, one second, sorry students, if you can remember this formula, then you can say all the factors affecting permeability can be clear. So here what is K? K is nothing but K is equal to D10 square C into E cube by 1 plus E into gamma W upon mu. So this is the formula for what, sir? This is the formula for what, my dear students? This is the formula for permeability. Actually, what does this? You should be careful. Here there is one paradox, sir. Let me tell you. If you see the particle size, if the particle size is increasing, permeability will also increase. What is effective size means? It is nothing but the size of the sea where 10% of the soil particles are passing. Similarly, next C. C is nothing but shape constant. Rounded particles are more permeable when compared to the angular particles. Because in rounded particles, the voids will be continuous. In angular particles, the voids cannot be continuous. So that is the reason, if you say in shape perspective, rounded particles are more permeable when compared to the angular particles. Now comes the important matter. Here if you see from this, if I take 1 plus E as E approximation, from this equation you can say that K is proportional to E square. But practically this is proven wrong, sir. And this is an important justification, my dear students. Always remember that more the void ratio, less the permeability. Less the void ratio, more the permeability. More the void ratio, less. So indirectly what it is saying is permeability is inversely proportional to void ratio. Why? Let me tell you. Sir, permeability doesn't depend upon the number of voids. It depends upon the size of the voids. That is why this relation, this about void ratio has reduced. Now coming to what is mu, sir? Viscosity. Suppose viscosity, more the viscosity, less the permeability. Less the viscosity, more the permeability. Simple example, sir. Permeability increases with increase in temperature with a decrease in viscosity. Suppose if I pour oil on the ground, oil will take more time to scatter. Once you heat the temperature, it loses its viscous nature and the flow will be fast. The same thing, that is the reason. So you have to remember that permeability, what are the factors affecting permeability is, permeability increases with increase in temperature with a decrease in viscosity. I hope you are clear with the factors. Now similarly, my dear students, let me tell you, we have different tests, sir. One is the constant head test. In the name itself, what is constant head test, sir? In the name itself, the head is kept constant. So actually to maintain the head constant in fine-grained soils, it is very tough, let me tell you, my dear students. So to maintain the head constant, it is possible in coarse-grained soils. You already know that velocity is equal to I into K. Now according to the continuity equation, or you can know discharge is equal to area into velocity, you can say that Q is equal to AIK. And let me tell you, this is the formula used for constant head test. In GATE, they can give you also another thing, students. Based on these three formulas, they have given 2 times in 23 as well as in 21 they have given. And you should also know the basic thing, what is discharge is volume upon time. And let me tell you, sir, 1 meter cube is 1000 liters. This is the common mistake everyone is doing in the problems calculation also. So let me tell you, constant head test is suitable for which type of soils? It is suitable for coarse grained soils. Next we have is the falling head test. Next we have is what, sir? Falling head test or variable head test. What, sir? They can also call it as falling head test or variable head test. Now let me tell you, sir, actually there is a derivation, amma. Here I don't want to waste your time on derivation part. So what actually is falling head test here, sir? Sir, falling head test is suitable for fine-grained soils and it is given by the formula AL by AT into Ln into H1 upon H2. So this is the formula for what, sir? Variable head test. Now variable head test is suitable for what, sir? It is suitable for fine-grained soils. So if you consider capital A and L, these are the area and length of samples, sir. So here what is this? You know already what is capital A? Area of the sample, and L is the capital L is the length of the sample. But whereas small a is the area of the standard pipe. Actually, my dear students, sorry, area of the pipe you can write. 1 second, students. Okay. This is area of standard pipe you can write. Okay. So this is all about the falling head test. And there was a beautiful question framed in this variable head test. In one of the IIS question, if a head is falling from H1 to H2 and head is falling from H2 to H3, then the heads will be in the relation of if all the parameters are kept constants. Sir, are you getting me? If a head is falling from H1 to H2 and then to H2 to H3, then the heads will be in the relation of if all the parameters are kept constant. So in this case, what you can write, sir? AL by AT can be written as L into H1 upon H2. Similarly, other parameters are constant. AL by AT is equal to Ln upon H2 upon H3. So if you cancel all these parameters here and here, you can say H2 square is equal to H1 H3. Sir, see, you might have known this. This relation is for what, sir? This is the relation for what? This is the relation for geometric progression. Okay. Now see, students, next we have is, see, permeability in a horizontal flow, or you can say a parallel flow. Sir, in a horizontal flow or a parallel flow, permeability KH will be equal to, formula is sigma I is equal to 1 to N Ki Zi upon sigma I is equal to 1 to N Zi. Sir, how this formula came, you can be asking me. Sir, in a horizontal flow, discharge will be summation. What, sir? Discharge will be taken as Q1 plus Q2 plus so on Q3 plus so on up to Qn. This is what the discharge says. Similarly, head loss will be constant, sir. H is equal to H1 plus H2 is equal to so on up to Hn. Now, if I do this, Q is equal to what, sir? A, because length is also same, because same sample. So here I can be written as I is equal to I1 is equal to I2. So if you write AIK is equal to A1 I1 K1 plus A2 I2 K2, so on, it will come. Now see, students, I cancel. And A can be written as what, sir? The total depth. If I have taken depths into perpendicular to the board, will take 1 meter, sir. So it can be written as Z1 plus Z2 so on up to Zn into what is this? This is the horizontal flow is equal to, here it will be Z1 into 1 into K1 plus Z2 into K2, Z2 into 1 into K2, so on. So if you solve this problem, this is how the derivation will be derived. Clear, sir? Now, similarly, permeability in vertical flow. What, sir? Permeability in vertical flow. So herein, if I talk permeability in vertical flow, how it is given, sir? Permeability in vertical flow is given as sigma I is equal to 1 to N Zi upon sigma I is equal to 1 to N Zi Ki. This is called the coefficient of vertical permeability. Now see, students, in vertical permeability, head loss will be summation. Okay, and discharge will be same. So based on this, they have calculated the permeability of horizontal flow and permeability of vertical flow. So you can always remember equivalent permeability is given by the formula square root of Kh into Kv. Okay, sir, how do you find out the Equivalent permeability is, you can always write equivalent permeability is KH is equal to, K equivalent is equal to square root of KH into KV. Now, I hope you are clear. Now see students, we will talk about the effective stress distribution, effective stress concept. The name itself, what sir? Effective stress. Sir, what is effective stress is, suppose see students, if I consider this as a soil particle sum, okay, and now suppose if a load is suppose applied here, and most of the people don't know, sir, let me tell you what exactly is the difference between effective stress and a stress distribution. Sir, effective stress is due to the self weight of the soil. Stress distribution is due to the external load. Are you getting me, sir? Stress distribution we always calculate for external load, whereas effective stress or total stress is due to what, sir? These are due to the self weight of the soil. This is an important point where you should be remembering the concept, sir. Effective stress should be what, sir? It should be the self weight of, suppose if I have applied a load here, okay, if I applied a load here, okay, what is effective stress? Sir, see, suppose there might be voids here. Total stress can be taken as stress taken by soil plus stress taken by water. So here see students, so total stress can be written as effective stress plus pore water pressure. Okay. Now see students, effective stress can never be calculated directly. We always have to know, because we cannot separate soil and water completely. So we have to find out the pore water pressure and we have to find out the total stress. So this is how, actually please understand students, total stress is nothing but effective stress plus pore water pressure. Okay, and pore water pressure is, sir, U is equal to what, sir? Gamma W into HW. This is the pore water pressure which you should be very careful. Now see students, let me discuss different cases, sir. Just a second students, I am trying to cover all the cases here. Now see my dear students, in the first case, okay, if the soil is having gamma unit weight and Z, what will be the total stress, sir? Total stress will be considered as gamma into Z. This will be the total stress. And what will be the pore water pressure? Pore water pressure will be 0. Why? Because there is no water table. So my dear students, first case you should say that total stress is equal to effective stress. Total stress is equal to what, sir? Effective stress when there is no water table. When there is no water table, you can say. Next thing, what? Why? Sir, see, next one I would like to tell you here is, if there is a surcharge loading, what, sir? If there is a surcharge loading Q, okay, if I tell you there is a surcharge loading. In this surcharge loading, how will be the stress distribution, sir? The stress distribution will be in this way. That means due to surcharge load, you can write here, what, sir? Due to surcharge loading, how is the stress, sir? Stress is, you can say stress is uniform. You can write like this. Okay. Now my dear students, suppose if there is a water table here. Okay. Now see, and what will be the depth of the soil if I take it as Z? And the condition of the soil is gamma set. Now see students, what will be the total stress, sir? What will be the total stress? Total stress will be equal to gamma sat into Z. What, sir? Total stress will be equal to gamma sat into Z. Pore water pressure is what, sir? Gamma W into Z. So if you do the minus, you will get gamma dash into Z. Gamma dash into Z. Why? Because gamma sat minus gamma W is what, my dear students? It is nothing but gamma dash. Now here what is the observation you have to do is, whenever there is a water table effect, effective stress is taken as gamma dash into Z, or gamma sat will be replaced by submerged unit rate. That point you should know, okay? Next, see students, suppose we have different soil status like this. If we have a soil state of Z1, Z2, and here we have gamma 1, gamma 2. Okay, in this case, the total stress distribution will be somewhere like this. So here what I would like to tell you, see students, here whenever these things are there, you should understand the slope changes. When in a soil of stratified soil, what's are here? Slope changes. Why does the slope change, Amma? Because it is having different gamma values. Why it is having? Because it is having different gamma values. Now, the most important topic, and this year I am expecting a question, sir. Okay, that is the earth pressure. What, sir? Earth pressure. When I talk about earth pressure, why do you want to study earth pressure is in the design of retaining walls, sheet piles, bridge abutments. All these cases you will be studying about what, sir? Earth pressure. So first in earth pressure, I will tell you some steps, so that please follow these steps and you will get all the questions solved. The first step is you have to find out the coefficient of earth pressure. What is the first step, sir? Any problem, my dear students, first step you have to do is coefficient of, you have to find out the coefficient of earth pressure. Suppose, how do you say that coefficient of earth pressure? Which earth pressure? Sir, they will not tell you active, passive or at rest. If there is no wall movement, then it is at rest pressure. If the wall moving is away from backfill, then it is called active earth pressure. If the wall is moving towards the backfill, then it is called passive earth pressure. So you should understand what actually is. Sir, why do we, sir, see, coefficient of earth pressure K is defined as horizontal stress upon vertical stress to be. Now, respect to earth pressures, if you calculate here, what is Ka, sir? Ka is equal to 1 minus sin phi upon 1 plus sin phi. What is Ka, sir? 1 minus sin phi upon what, sir? 1 plus sin phi. What is Kp? Kp is nothing but 1 plus sin phi upon 1 minus sin phi. So first step, if it is active earth pressure, you will find out active. If it is passive, you will find out passive. Similarly, at rest pressure, K naught is equal to what, sir? Mu into 1 minus mu in terms of Poisson's ratio, or in terms of friction, it is 1 minus sin phi. So these are all the magnitude, coefficients of earth pressure. Now see students, here from this, first step is what, sir? Coefficient of earth pressure. Always remember that Kp is greater than K naught greater than Ka. This is the order of the earth pressures. Now, what is the agenda of this horizontal coefficient of earth pressure is, sir, see, always we know the vertical stress. So, actually earth pressure is a horizontal pressure. So, suppose if you have a resultant, Amma, if you consider this as a F, so what will be this value, sir? It will be equal to F cos theta. And what will be this value, sir? This value will be equal to F sin theta. Am I correct or wrong? So, to this if you are taking, similarly to convert this vertical stress into horizontal component, we take sigma V into K is equal to what, sir? Sigma H. So, this is what you have to do for finding the horizontal stress. Clear, sir? So, horizontal stress can be taken as K into sigma V. So, this is the first point I would like to tell you. Next point, step 2. Sir, step 2 is find out the total stress. What, sir? Find the total stress and draw the diagram. What, sir? Find the total stress and draw the diagram. Okay. Now here I will tell you one important thing, very very important note, sir. Here what is the important note here is, if there is a pore water pressure, what sir? If there is a water table, or you can say, if there is a water table, this is mandatory, sir, I will tell you. If there is a water table, total stress should be written as what, sir? Effective stress plus pore water pressure. Why total stress should be written as effective stress plus pore water pressure? Sir, I told you we are resolving the vertical component to horizontal component by multiplying with coefficient, right? But what happens here is, suppose according to Pascal's law says that pore water pressure is same in all directions. What does Pascal's law say, sir? Pascal's law states that pore water pressure is same in all directions. When pore water pressure is same in all the directions, what, sir? You need not to multiply U with K. So K will be equal to 1 in case of pore water pressure. Are you getting, my dear students? Sir, what is the intention of multiplying with coefficient of earth pressure? To make vertical component horizontal component. But what does Pascal's law states? It states that pore water pressure is same in all directions. So you have to take the value of coefficient of earth pressure as 1 in case of pore water pressure. This is a very important note. Now see, students, step 3. What is step 3? I will tell you. Step 3 is nothing but calculation of earth pressure. What, sir? Calculation of earth pressure. So calculation of earth pressure, what is calculation of earth pressure is, from these steps you can just multiply 1 multiplied with 2. But here, my dear students, in calculation of the earth pressures, there can be active earth pressure or there can be a passive earth pressure or anything. So what I will write here, if it is active earth pressure, we take it as what, sir? K into sigma phi. These are the values for cohesionless soils. So I'll write for cohesive soils, then you can write for cohesionless. Just substitute cohesionless means minus 2c root k. Cohesionless means it should be 0, sir. C should be 0. Always remember this. Similarly, what will be the passive pressure, sir? Passive pressure is nothing but Kp into sigma v plus 2c root Kp. Similarly, if they ask you for at rest pressure, you can say K0 into sigma v. And remember, my dear students, in case of, they need not to tell whether the soil is cohesionless or anything. If you see, they have given the soil as sand and gravel. What, sir? If they have given the soil as sand and gravel, C will be equal to what, sir? 0. C will be equal to what, sir? 0. So remember, my dear students, in the step 3, the calculation of earth pressure, you have to multiply step 1 or follow this. Next, the step 4 can be what, sir? The step 4 can be the area of the pressure diagram. The area of pressure diagram is what, sir? The area of pressure diagram is nothing but force. What is the step 4, sir? Area of the pressure diagram is nothing but the force. Always remember, see students, the area of the pressure diagram is force. So how do you calculate force here is, active force is given by the formula of Ka gamma z square minus 2c, where is c 2c root Ka z, and similarly what is Fp is half Kp gamma z square plus 2c root Kp into z. Remember, my dear students, if you see here, I have shown you this also, but how actually you can remember this chart also. If I consider this as when you move away from the wall, active earth pressure is reducing. When you move, when it is stationary, it is at rest pressure. When you move towards the backfill, then it is Kp. Okay. So these steps will definitely help you. Now, where does this force act? If you consider step 5, where does this force act is? Force act at its centroid. And force act, please follow these steps. Remember, my dear students, whenever, see, let me tell you, if you follow these steps, you will be very easily solving, students. Now, this can be a question, sir. Suppose, see, students, we have 2 layers. Suppose here it is phi 1 and here it is phi 2. Okay, sir. Now based on the phi 1, if or you will have Ka1 and here it is Ka2. Suppose, see students, if Ka1 is greater than Ka2, okay, now at the interface, the diagram will come like this. That means whatever the stress which you have calculated at the center, you should multiply with Ka1 and here you will multiply with Ka2. Are you getting me, sir? For top and bottom, anyhow you are confident. You will take with 1 and you will take with 2 here. But at interface, you have to consider the both the values. Similarly, in passive, suppose in the other cases, if Ka1 is less than Ka2, then the diagram will be like this. Then Ka1 will be less than Ka2. Similarly, C students, if we have different C also, here we have to calculate the both the values. Are you getting my dear student? At interfaces, you have to calculate both the values taking Ka1 and Ka2 into account. Okay, so please write down this students. I'll be back in 2 minutes. Now see students, I hope you have written this. Okay, I hope you are clear with the thing. Now in earth pressure, my dear students, there is one more important topic, there is a concept called tension crack depth. What, sir? Tension crack depth. What is tension crack depth, sir? What is tension crack depth? You can say here, tension crack depth means it is the depth at which active pressure is 0. What, sir? PA means what? It is the depth at which active pressure, is 0. See here, what is active pressure, sir? Here you can write PA is equal to Ka into sigma V minus 2c root k, right? Now see students, what I can write sigma v. Suppose the tension crack depth, it will be like this, sir. This we call it as ZC. So we can write as Ka into gamma ZC minus 2c root Ka 0. So if I write here, ZC can be written as what, sir? 2c by gamma root Ka. What, sir? ZC can be written as 2c by gamma root Ka. Am I correct or wrong? So what is ZC here? ZC is nothing but what, sir? Depth of tension crack. What is ZC, sir? ZC is nothing but depth of tension crack. Similarly, if they ask you, what is critical height? What, sir? Or critical height or critical depth or whatever. Sir, see, suppose if you are trying to excavate a soil from here and you are trying to place the soil here. Okay, you are trying to excavate the soil and you are trying to place the soil here. So what is this critical height means? It is the height at which an excavated soil it is the height at which an excavated soil can withstand without any lateral support. What, sir? Can withstand without any lateral support. It is the height at which an excavated soil can withstand without any lateral support. So this is what, sir? This means, or you can say here in critical height, you can write here as what, sir? It is the depth at which active force is 0. Okay, it is the depth at which active force is 0. So you can write here half into Ka into gamma hc square, no? Gamma hc square minus 2c root Ka into hc. Minus 2c root Ka z, no? Here it is, hc is what, sir? Critical height. So hc can be written as, from this very important formula, hc can be written as 4c by gamma root Ka, or you can write it as 2 into zc. Or you can write it as what, sir? 2 into zc. So hc is equal to what, sir? 4c by gamma root Ka, or you can write it as 2 into zc. So here hc is called what, sir? Critical height. Clear, my dear students? Now, similarly, we will discuss another important topic is stability of slopes. Sir, when I talk about stability of slopes, there can be various reasons for stability of slopes reason. The slope can fail due to like earthquake force, seepace force, or any other disturbance which is created. So actually in slopes, there are two slopes, sir. Actually in slope, there are two slopes. One is finite slopes and other one we have is what, sir? Infinite slope. So what is finite slope and what is infinite slope is, if you say in infinite slope, what, sir? If you say that in infinite slopes, slope length is, in infinite slope, what is, sir? Slope length is unlimited. Okay, in finite slopes, you can say slope length is limited, you can say. Sir, this is the basic thing anyone can ask me by looking into the definition only. So when I say that slope length is limited, this is observed which failure, sir, here? In finite slopes, we observe rotational failure. What we observe in finite slope, Amma? We observe rotational failure in finite slopes. Any doubts in this, sir? And where do you observe? In infinite slopes, you will observe translational failure. In infinite slopes, what do you observe, sir? Translational failure. And let me tell you, see students, you know already better what actually is rotational failure. Sir, in rotational failure, it occurs along a curved surface. What, sir? It occurs along a curved surface. Agree, my dear students? Similarly, if you talk about the translational failure, where it occurs, sir? It occurs parallel to the slope. What, sir? It occurs parallel to the slope at some depth. So, see students, basically soil slope failure might be due to earthquake force, seepage force, uplift force or any other force. So, basically there are two failures. One is translational failure and rotational failure. Translational failure is observed in infinite slopes, rotational failure is observed in finite slopes. And rotational failure occurs along a curved surface and translation failure occurs along a parallel to the slope. Now, my dear students, if I talk you about the factor of safety, what, sir? If I talk about the factor of safety for translational failure, if I talk you about the factor of safety for translational failure, what is the factor of safety for translational failure, sir? It is nothing but what, sir? Shear stress by shear strength. What is the factor of safety? It is nothing but shear stress by factor of safety is defined as what, sir? Factor of safety is defined as shear stress by shear strength for translational failure. That means if this is a slope, Amma, it will act at some depth parallel to the slope. And you can say that angle of infinite slope is I. So, here see students, the generalized formula I will tell you after derivation and all. It is given by the formula C plus gamma z cos square I tan phi. What is I, sir? Angle of infinite slope. So, you can write factor of safety is equal to, this is shear stress. Sorry, sir, small change here. Factor of safety for translational failure is given by shear strength upon shear stress, sir. Okay, please keep a note of it. It is not shear strength upon what, sir? Shear stress. Okay, here, so this will be given as C plus gamma z cos square I tan phi upon gamma z cos I sin I. Okay, this is the formula for what, sir? This is the formula for factor of safety for which soil? This is the factor of safety for C5 soil. Now, my dear students, for cohesionless soils, they can ask you, just substitute C0 there. So, gamma z cancel, and if you do that, you will get the answer as tan phi upon tan I. The factor of safety for translational failure will be what, sir? It will be getting as what? Tan phi upon tan I. And remember, this is another important question, sir. For a slope to be stable, what, sir? For a slope to be stable, sir, see, for a slope to be stable means factor of safety should be greater than 1. Yes or no? Factor of safety should be greater than 1. When will be the factor of safety greater than 1, sir? If I is less than 5. If I is less than 5, then the factor of safety will be more. Please write down that. Now see students, this is a very important point which I am telling you now. This we can expect means 3 to 4 times we have expected this question, sir. Now see the factor of safety for translational failure, the factor of safety for translational failure in case of seepage. What, sir? The factor of safety for translational failure in case of seepage is given by the formula gamma dash upon gamma set into tan phi upon tan I. What, sir? Gamma dash upon gamma set into tan phi upon tan I. Okay. Are you getting me, sir? Always gamma dash will be less than gamma set. Okay. That is also you have to keep in mind. Now see students, when I talk about the factor of safety for rotational failure. What is the factor of safety for rotational failure, sir? What is the factor of safety for rotational failure? Anyone, my dear students? It is defined as the ratio of resisting moment by driving moment. What is the factor of safety for rotational failure? It is defined as the ratio of resisting moment upon, it is defined as the ratio of resisting moment upon driving moment. Okay. So what actually is, what do you mean by resisting moment and what do you mean by driving moment? We will discuss here. Sir, see, first we will have a concept here. Just a second, students. Now see, students. Here the failure surface is assumed as an arc of a circle. Weight acts downwards. This is the radius, centroidal distance of point of rotation O, and this is the radius. Sir, see, the resisting moment will be occurring due to what, sir? Cohesion. Okay, but see, students, this is equal to, this is a method where phi u is equal to 0. Okay, in this case, what will be the see, obviously driving moment is due to what, sir? Weight. So it will be taken as weight into x bar, right? Similarly, what will be the resisting moment, sir? Resisting moment will be C. C, cohesion, which is acting along the length and perpendicular to the board, you take it as 1. So this entire thing is what, sir? Stress into radius r. So this is the moment, means lever arm distance or what you can say. So if they ask you factor of safety for rotational failure for phi u is equal to 0 analysis, it is CLR upon W into x bar. So this is the factor of safety for rotational failure in case of what, sir? In case of phi is equal to 0 analysis, in a broader picture, you just remember this. Okay. Now they can ask you, sir, in a Swedish circle method. Okay. Factor of safety for Swedish circle method is CL plus sigma n minus u into tan phi upon sigma t. Sir, in Swedish, this is the formula for factor of safety for what? Rotational failure in case of which method, amma? In case of, this is the formula for what? Swedish circle method. Sir, the important observation what you have to do here is, see students, the sum of the tangential forces, these are only responsible for driving moment. Okay. Tangential. And normal forces are responsible for resisting moment. Okay. And remember, my dear students, when they ask you what is the radius of friction circle, what, sir? They can ask you what is the radius of friction circle. The radius of friction circle is what, sir? It is nothing but r sin phi. The radius of friction circle is what? R sin phi. Clear, students? Similarly, we have Bishop's method also. The factor of safety for what, sir? The factor of safety for rotational failure using Bishop's method. Actually, in Swedish circle method, amma, the curve is substituted in the form of slices. If you consider this as a failure surface, sir, and if this is a curve, the failure surfaces is assumed in the form of slices. But they never considered the forces which is in between the slices. But in Bishop's method, it was considered. So here the factor of safety is given by the formula C plus sigma tan phi upon please C plus Cm plus sigma tan phi m. This is the factor of safety for what, sir? Bishop's method. And here you should understand what is phi m and Cm, sir. This is the mobilized cohesion. Mobilized means cohesion or friction. It is a changed part, sir. So as the force, then you also remember Cm will be equal to 2/3 of C. Similarly, see students, in stability of slopes, we also have stability number. Okay, stability number is given by the formula C into Fc into gamma into H. Okay, this is an important formula. Stability number we call. Next, now see students, when I talk about consolidation, sir, we have consolidation. Sir, what do you mean by consolidation here? Sir, see, in soil, if I consider this as a soil mass and we have the soil particles, in this, sir, see, there will be some water, right? So remember, my dear students, what is consolidation is it is a very slow process, sir, let me tell you. Okay, see, it is the removal or you can say expulsion of water. It is the expulsion of water under study static long term pressure. It is the, okay, sir. And let me tell you, it is a very slow process. Let me tell you, see students, it's a very slow process. In consolidation, we have one is initial consolidation, and next we have is primary consolidation, and next we also have what, students? Next we have is the secondary consolidation. What we have, sir? Next we have is the secondary consolidation. So how much we have different stages of consolidation, sir? One is the initial consolidation, next we have is the primary consolidation, next we have is the secondary consolidation. Sir, the definition of consolidation says what? Removal of water. But initial consolidation is not removal of water, it is removal of air. Sir, actually consolidation happens in clays and saturated soils. But let me tell you, initial consolidation happens in partially saturated soils. Just if you apply the load, the air will be going out. So that is a kind of actually terms compaction theoretically, but practically it is initial. Primary consolidation means it is the removal of water of voids, then it is called primary. Secondary consolidation means there will be highly viscous water. That water, if you remove, either the soil particles will come closer or they move apart. So plastic readjustment of the soil particles will happen in secondary consolidation. And remember, in secondary consolidation is very important. This secondary consolidation is proportional to logarithm of time. Sir, most people can ask me, sir, why can't it be proportional to time? Why it is proportional to logarithm of time? Sir, logarithm for huge value, the value will be small. Suppose log 100, what is the value, sir? 2. So it says that logarithm means for huge time the value will be less. So secondary consolidation occurs only after primary consolidation. Secondary consolidation occurs at constant effective stress. This is all the important things in the stages of consolidation. Now see students, one second, student. Now we have a concept called Terzaghi piston model. What we have, sir? We have this concept called, this is called Terzaghi. We can call here Terzaghi piston model, or we also call it as spring analogy model. What, sir? Or we can also call it as spring analogy model. So how it will look like? This is the spring, and here we have the surcharge, and here we have a pipe kind of stuff, and here it is something which is shown as valve. Okay. Now see students, here valve is considered as what, sir? You might be aware, valve is considered as what? Permeability. Why valve is considered as permeability, sir? If you open the valve, water will flow. If you close the valve, water will not flow. So here there can be water here. Okay. So here spring is considered as what, sir? Spring is considered as soil. Now stress on water is considered as what, sir? Stress on water is considered as, sir, why? Because consolidation happens below the soil. To virtualize it, we are creating a model. Suppose if you are constructing a dam, you will make a prototype and you will analyze it, sir. Similarly here, stress on water is what, sir? This is pore water pressure. Stress on soil is called what? This is called effective stress. Okay, sir. This is what, sir? Pore water pressure. This is sigma dash is what, sir? What is sigma dash, sir? This is called effective okay. Next, valve, spring, stress on water, stress on soil, and next one we have is what, sir? Cylinder. Cylinder is nothing but voids. What is the cylinder we have, sir? Cylinder is nothing but voids. Agree, sir? So this is how the Terzaghi piston model. Now next, let me tell you the important formulas, sir. In now see students, important formulas in consolidation. Okay, sir. Now see, what are the important formulas we have is, first we have is coefficient of consolidation. Coefficient of consolidation CV is given as K upon MV into gamma W. What is K, sir? Coefficient of permeability. What is MV? Coefficient of volume compressibility. So volume compressibility is given by the formula delta V by V into delta sigma dash. This also can be written as delta H by H into H into delta sigma dash, because area will be same. So here settlement can also, next AV can also be written as, it is the ratio of decrease in void ratio per unit increase in effective stress. Okay, sir. Now see students, you know already delta H, it is the formula very important, sir. This is the formula for settlement. Delta H is equal to what, sir? Delta H is equal to MV into H into delta sigma dash. This is what, students? This is the settlement. Okay. So here delta H can be written as what, sir? Again H into Cc plus 1 plus E naught into log of sigma initial stress plus delta sigma into upon sigma dash. And remember, see students, here when I talk about degree of consolidation here, degree of consolidation is settlement at a time by ultimate settlement. And you know time factor is given by the formula CVT upon D square. Okay, sir. Now, if the degree delta H by H can also be written as delta E by 1 plus E naught. Okay, this is another important relation. Now see students, let me explain you some kind of a problem where they usually ask, sir. Now see students, if they ask you how to calculate the settlement, I told you already, we have told already. What is delta H, sir? Delta H can be written as what I will tell you here. What is delta H here? Delta H is nothing but H into Cc upon 1 plus E naught into log of sigma final effective stress upon sigma initial stress. Okay, sir. See here, first of all, you should understand what is H. H is nothing but thickness of clay layer only. Sir, in the strata, it contains whatever. H is what, sir? H is the thickness of clay layer only. Okay. No other thick soil you cannot take. Okay. And now, what is Cc, sir? Cc, what is Cc? Cc is a coefficient of compression index. This will be taken as 0.009 into WL minus 10 for undisturbed sample. If it is a function of liquid limit, Cc can also be written as delta E upon log of sigma final upon sigma initial. This is also Cc. Okay. Sir, see now, here if you consider here, what we have considered is, we will follow some thumb rules, sir. Here, see, if this is entire soil, here you have to consider the first, please see students, here sigma naught, that is effective stress. Sir, these points are very important in solving the problem of effective stress will be always calculated at center of clay layer. Where, sir? It is always calculated at effective stress. Where it is calculated, sir? Effective stress is always calculated at center of, it is always calculated center of clay. Effective stress is calculated at center of what, sir? Clay layer. Am I correct or wrong? Now, delta sigma, here we also have, I told you, final effective stress is nothing but is equal to sigma naught plus delta sigma. Sir, delta sigma is something whatever the load which is supposed to act on the soil. Okay. Now, how do you take the area, sir? This area you will consider in three-dimensional way. Okay. So, in three-dimensional way, if you consider this area, whatever the area which I am showing here, okay, whatever the area at the center of clay layer, if you are finding, sir, we used to follow 2:1 method. So, in this case, delta sigma can be written as Q upon L plus Z into B plus Z. 2:1 ratio method if you follow, you will get this. Okay, sir. Sir, see, they can ask you in the other ratio problems, we have TV is equal to what I told you, CVT upon D square, sir. Sir, here C also, here D will be taken as H, thickness of clay layer, in case of single drainage. In case of what, sir? In case of single drainage, D will be taken as H in case of single drainage. D will be taken as H by 2 in case of what, sir? In case of double drainage. And always remember, sir, see, if they tell you same amount of consolidation, you should be clear. Suppose, see, time factor, if I tell TV is equal to CVT by D square, and you should also have an idea, coefficient of consolidation is K into MV by gamma W. And you should also know this thing, if degree of consolidation is less than or equal to 60 percentile, time factor is given by the formula pi by 4 into mu percentile by 100 whole square. What, sir? It is given by the formula pi by 4 into mu percentile by 100 whole square for a time factor TV is equal to pi by 4. Now, similarly, If the degree of consolidation is greater than 60 percentile, time factor is given by the formula 1.781 minus 0.933 into log of 100 minus u. Okay. So TV is equal to what, sir? 1.781 minus 0.933 into log of 100 minus u. Clear, sir? So these relations, they might give you in the problem, and from this you have to develop a relation also, sir. Okay. This is all about consolidation. Similarly, they can ask you related to shallow foundations. Sir, in shallow foundations, what is a shallow foundation is? This is quite simple. Shallow foundation is something like this. If the depth is less than or equal to width, then we say that it is a shallow foundation. Or a foundation is considered as shallow if rotational failure is possible. Or what, sir? A foundation is considered as shallow if rotational failure is possible. Now see, students, here you have told depth is less than or equal to width, then it is what, sir? Shallow foundation. Agree or not, my dear students? Yes or no? Now see, students, we have here gross pressure. What is gross pressure, sir? It is the total pressure at the base of the footing due to weight of superstructure, substructure, and you can say it is the total pressure at the base of footing due to weight of superstructure, not substructure, self weight of footing or earth fill. Similarly, we have net pressure. Net pressure is nothing but gross pressure minus gamma d. Similarly, we have ultimate bearing capacity. What is the ultimate bearing capacity? It is the maximum the pressure that can be applied without shear failure. Or if you see, usually we have two terms, net safe bearing capacity. What is net safe bearing capacity is net ultimate bearing capacity upon factor of safety, and we also have net safe settlement pressure. Sir, actually in foundation there are two things. Foundation can fail in two ways, sir. One is shear in terms of soil, and foundation can fail in terms of settlement in terms of soil. In RCC it is one-way shear or two-way shear. So actually shear will help you to find out the depth of the foundation. So when we take about a shear failure, we take into account the net safe bearing capacity. Okay. If you want to take settlement as the thing, then you will take what, sir? Net safe settlement pressure. So my dear students, in foundation, it should not happen both, sir. The soil should, the foundation cannot fail both ways. It cannot fail in both shear, or it cannot fail in both settlement. So they have come up with a term called QNA. That is, QNA is the net allowable bearing pressure, and if I take QNP is the net safe settlement pressure, and if I take QNS, net safe bearing capacity. So QNP is what, sir? It is the net pressure that can be applied without shear failure or without excessive settlement. So that is the reason they take the minimum of these two. That is the reason they take what, sir? Minimum of these two. So this is all about the design. So in design of foundation, what they will use, net allowable bearing capacity, because it will not allow the net settlement, also it will not allow the net shear failure also. Now see, students, we have a Terzaghi theory model. In Terzaghi theory model, sir, the rate of change of pore water pressure, all those things will be there. Shear strength is calculated by Coulomb's equation, and also you can say the see, you have to understand soil is homogeneous, isotropic. These are the assumptions. Now my dear students, if I talk about the ultimate bearing capacity for a circular footing, circular footing is given by the formula CNC plus gamma D, okay, 1.3 CNC plus gamma D NQ plus 0.3 gamma B N gamma. Okay, sir. Sir, here similarly they can ask you for square. What is the ultimate bearing capacity for square? So ultimate bearing capacity for square is 1.3 CNC plus gamma D NQ plus 0.4 gamma B n gamma. Similarly, if they ask you for ultimate bearing capacity for rectangle, it is 1 plus 0.3 B by L CNC plus gamma D NQ plus 0.5 gamma B N gamma into 1 minus 0.2 by B by L. Okay, sir. These are the ultimate bearing capacity for circle, square and rectangle. If they ask you for strip footing, okay, if they don't mention any footing, then you have to take this, sir. CNC plus gamma D NQ plus 0.5 gamma B N gamma. And remember, my dear students, here if you ask me here, you should be very careful. Here, if you ask me here, what is NC, NQ and N gamma? Remember, see students, NC, NQ, N gamma are called the Terzaghi bearing capacity factors due to cohesion, due to surcharge and also due to the unit weight. Suppose if they have given you for pure cohesive soil, sir, pure cohesive soil means what, sir? Phi is equal to 0. And remember, all these Terzaghi factors is a function of phi. Sir, are you getting me? NC, NQ, N gamma are always functions of what, sir? A function of angle of internal friction only. Suppose if phi is equal to 0, NC value will be equal to 5.7, NQ value will be equal to 1 and N gamma value will be equal to 0. So you have to keep this in mind. What, sir? NC is equal to what? 5.7, NQ is equal to 1 and N gamma is equal to 0. So these are all the Terzaghi bearing capacity factors due to what, sir? Circular footing, square footing and also what, sir? Rectangular footing. Okay, please write down this, students. Okay, sorry students, I hope you have written this. Next, sir, see, if I talk about a plate load test, what is the agenda of plate load test is, see students, suppose if we have drawn a schematic diagram here, if I have drawn a schematic diagram here, or you can say line diagram. If you start applying a load on the plate, the load at which the plate starts sinking is known as what, sir? Ultimate load. How much the plate has sink, then it will be the settlement. So for clays, sir, this is important formulas, sir. Settlement, plate load test, important formulas. SF by SP is equal to what, sir? BF by BP. What is SF by SP? Settlement of foundation upon settlement of plate is equal to breadth of the foundation upon breadth of the plate. Similarly, if I talk about sands, what is settlement of foundation by settlement of plate, sir? Settlement of foundation out of settlement of plate is breadth of the foundation upon BP plus 0.3 and BP into BF plus 0.3. Sir, whole square. And remember my dear students, here very important note, breadth in this formula only. Sir, here both is a ratio, so it will cancel. Here breadth of the foundation and breadth of the plate, both should be in what, sir? Both should be in meters. Okay. Next we also have standard penetration test. What, sir? Standard penetration test. What is standard penetration test means? It is the number of blows required for 30 centimeter penetration. Sir, actually there are two corrections. One is dilatancy correction and other one is the overburden correction. What is are you getting me, sir? What is SPT means? SPT is nothing but a number. It is the number of blows required for 30 centimeter penetration. Based on SPT, you will get an idea of the soil, whether it is soil is hard or whether it is soil is loose. And similarly, you will get a rough idea on the shear strength also. Hammer weight 75 kg, height of walls, you need not to worry about the hammer weights and all. Just follow this. When you talk about overburden, corrected value is given by the formula N into 350 upon sigma plus 70, whatever the value SPT. This is the correction for overburden, sir. What happens in overburden is, if it is shallow foundation, you will assume less value. If it is a deep foundation, you will assume high value. For a uniformity, you will do overburden correction, and this sigma cannot be more than 280 Newton per mm square. Similarly, correction for dilatancy is equal to recorded value 15 plus, means in case of water table is there, these corrections will come 15 plus NR minus 15 by 2. So this is the formula for penetration test. Clear, sir? Now see students, one second. Let me tell you, we have pile foundations. Pile foundation is also called as what, sir? Pile foundation is also called as deep foundation. What, sir? Pile foundation is also called as what, students? This is also called as deep foundation. Now see students, if I consider a pile here, just a second. If we consider the ultimate load here, Q as the ultimate load, okay, we have another load that is QB. And we have this load as QS, suppose. Now see students, if I see here, total ultimate load can be written as end bearing load plus load due to friction. Okay, this again can be written as end bearing resistance into area of the area at the base to Fs into ES. Okay, sir. Now, my dear students, what is FB? What is FB, sir? This is known as end bearing resistance. What is FB? This is called as end bearing resistance. What is AB, sir? For a circular pile, if you take it as, it will be pi by 4 d square. And this is called skin friction resistance. What, sir? This is called skin friction resistance. And AS is the surface area, that is pi dl. What is the area, sir? Surface area AS is what, sir? The surface area, that is pi dl. Now see students, what is for clays? Okay, for clays, FB is equal to C into NC, and NC value will be taken as what, sir? 9. And Fs will be taken as alpha C. For normally consolidated clays, alpha will be taken as what? Okay. So see students, what will be the ultimate load here is, for clays, CNC into AB, that is pi by 4 d square, plus alpha C into surface area, that is pi dl. This is for clays. Now see, similarly, my dear students, if they ask you for sands, see for sands, see students, ultimate load QU is given as FB into AB plus FS into AS. Yes or no, sir? Now see students, what you have to do here. Here I will tell you what to do FB. Sir, FB is nothing but what, sir? Can anyone tell me? FB is nothing but sigma V into NQ. And here sigma V can be written as gamma into L if L is less than or equal to DC. Critical depth 10 times, okay. What is L, sir? Length of the pile. And sigma V is equal to gamma into DC if DC is less than or equal to L. Similarly, what is F, sir? F is nothing but K into sigma average into tan delta. So these are the very important formulas which you have to remember for clays and sands for finding the ultimate bearing capacity. Now see students, what is group efficiency? If they ask you what is the efficiency of pile group, it is the ratio of pile group, average load on the pile group to the single isolated individual pile, to the ultimate load of single isolated individual pile. So this is what actually is into 100, this will be your efficiency. Sir, in piles actually, pile we have block failure. Suppose if I have taken these as the piles here. Okay. Sir, for finding the pile group capacity, if I want to find out the group capacity of the pile, if you want to find out the group capacity of pile group, there will be two failures, sir. What are the two failures? Can anyone tell me? In group capacities, there can be two failures, sir. One is the individual failure. In individual failure, group capacity can be taken as number of piles into ultimate pile. Okay, whatever the formula. But in a block failure, it will be taken as FB into capital AB plus Fs into capital AS. Suppose area of the block will be equal to what, sir? Here if the spacing between them is S, this will be equal to L0 into B0. But here what is L0? 2S plus dia of the pile, and it's a square group, no? So it will be also 2S plus D. I hope you are following what is this. Now similarly, there can be a concept called negative skin friction. So due to negative skin friction, what happens is the soil bearing, the load carrying capacity of the soil will be, load carrying capacity of the pile will be reduced because there will be a uplift force. When they ask you here, when I talk about individual failure and block failure, in group capacity, we will take the minimum. Are you getting me, sir? Sir, negative skin friction, in the name itself, it is negative. That means if the pile has to carry 1000, what you have calculated through negative skin friction, you have to reduce. But if they ask you for negative skin friction, in case of group, then you have to take the maximum value. And negative skin friction only you have to calculate Fs into As because this is due to the friction only. So don't take in negative skin friction. It is my sincere advice, my dear students. You should not consider the sir, in negative skin friction, what, sir? You should not consider what you should not consider. Can anyone tell me? What you should not consider, sir? In negative skin friction, you always feel that there should not be any account of taking off and bearing into account. Okay. So this is all about the soil mechanics, sir. So see students, I hope you have enjoyed the session. So tomorrow I'll coming in live on transportation topic at the same time 12 to 3. See students, the faculty will be more enthusiastic and more energetic if the students will involve in live chat and try to attend the sessions. Now see students, as we are inching towards the GATE exam, so people want to test themselves. They have prepared the whole 1 year and they want to test themselves. So in this testing, you should have an idea on your what are the mistakes you are going through and how you can overcome, what should be the guidance. Like if you consider in a gate coaching, you might have cross 1 year of coaching. In that, what topics you have to do extra attention. Also for this, to practice yourself, my dear students, Test Series Plus is a very important tool. So we at IMS Gate Academy are offering the Test Series Plus product, and whoever are interested, my dear students, the link is given in the description. They can just fill the link and you can get all the details. In addition to this, in this Test Series Plus, we are providing 130 plus online tests. It should be subject test, chapter test, multiple subject test, and we also provide you 33-year previous year GATE question booklet. See, my dear students, GATE previous year questions plays a very important role to be a successful GATE student. And we also provide the video solution for the typical problems. In addition to this, we have doubt solving portal, we have online revision score booster, we have post guidance, we have PSU mock guidance. So actually, after securing the GATE exam, now we have top NITs. Previously we used to have a limited 7 number of IITs, but we have come up with a new IITs, and we have come up with new NITs. So in this, if you want to clarify for which GATE score, which college will be more helpful, and what kind of placements are there, and even with the 1500, 1600 GATE score, we have rank, we have seen admissions from IISc Bangalore last year. So GATE guidance is a very important thing, my dear students. And you name any exam, you have to test yourself, because when you do some time bound tests, no, then you will get an idea what actually you are facing the challenges. And let me tell you, most important thing, students, if you have the GATE experience, like using virtual calculator, once you are doing time bound test but still you are habituated to scientific calculator, you please try to avoid it now, from at least from now, because scientific calculator will make a very big problem. Try to use the virtual calculator and get habituated to the GATE exam. I hope this Test Series Plus will help you to overcome all your things. Okay, now my dear students, let me tell you what we do at IMS Gate Academy. Now see students, we at IMS Gate Academy offers like offline gate coaching, online gate coaching, and also we are offering the hybrid model. So what we do at online gate coaching or offline gate coaching is, we are offering 800 plus hours of gate coaching. In this, we are providing the chapter test, subject test, exercise book at 33 plus years previous year questions. In addition to this, we are giving you the most important My Plan sessions. In these My Plan sessions, the entire journey we will be discussing in how you have to prepare for the one year course preparation. The entire years we will be discussing the preparation, students. So if you have any queries, you can just contact the below contact numbers. They will definitely help you for your things. So my dear students, I hope if you want to join our Telegram group link, Telegram group link is provided in the description. You can just click on the link in the Telegram group. Every day we will be providing the quizzes. In addition to these quizzes, we are also providing the actual thing, like whatever the PSU job notifications, all those things, general information related to the GATE and what could be the better opportunities through GATE. All these things will be posted in this Telegram group. Just click on the link and join. Now, I hope this video will help. I hope this session will give you some confidence on the subject geotechnical. And let me tell you, my dear students, the key success for any student for the GATE exam is consistency. So follow 3 important points. The first point is, make a formula sheet for every subject and try to revise as much as you can. The second important thing is, you should have a proper short notes. And the third important thing is, instead of solving various questions, try to solve all the previous year questions. But the most important trick in the solving the previous year questions is, you should be able to solve the previous year questions with a detailed understanding of the questions. You should have in and around concept of this, and how these concept key pointers you can remember. I hope this session will help you, and tomorrow we'll join. I hope everyone will join for the transportation session also. Thank you and all the best.